Hi everyone. In this video we're going to be learning some more about electrostatics, and we're going to answer a common Regents question that asks which charge could be found on an object. So our example is from 2012, it's question number 4, and it says a particle could have a charge of, and then we have to pick which one of these is a possible charge that a particle could have. I put a box around could because sometimes you'll see a question that says a particle could not have a charge of something, and it's important to know that we're looking for something that is possible. I also put a box around charge because that's kind of the topic of this question, is electric charge, or more specifically elementary charges. So I see on the front page of my reference table that one elementary charge is equal to 1.6 times 10 to the negative 19 coulombs, and that's going to be useful information for us for this problem. The rule that we're following is that charge on an object must be a whole number of electrons. Now it's not just as simple as picking the whole number because, first of all, none of these are whole numbers, but even if they did look like a whole number, this is coulombs, it's not electrons. So we are supposed to convert into electrons or convert into elementary charges in order to figure out what the answer is. Our strategy is just going to be convert each of our answer choices into electrons, and then we'll pick the whole number. So how do we convert from coulombs to electrons? It might help to think of each electron as a bucket that holds a certain amount of charge, and that charge is 1.6 times 10 to the negative 19 coulombs. So for example, this bucket would represent one electron, and I would put 1.6 times 10 to the negative 19 coulombs in it. That's how much charge this bucket can hold. So my total charge in this case would be 1.6 times 10 to the negative 19 coulombs. That one is pretty straightforward. If I had two electrons, or two elementary charges, I would have to use two buckets to hold this much charge. The first one has 1.6 times 10 to the negative 19 coulombs. The second one has 1.6 times 10 to the negative 19 coulombs again. And to see how much total charge I have, I would just do 2 times 1.6 times 10 to the negative 19. And that would give me my total. So that would give me 3.2 times 10 to the negative 19 coulombs. The general rule being, if we have a certain number of electrons, you multiply that by the amount of charge on each electron. So here, if I wanted to find the total charge, I would just do 3 times 1.6 times 10 to the negative 19 coulombs. And that would not give me 3.2. That would give me 4.8 times 10 to the negative 19 coulombs. How we can apply that to our Regents question is a little bit backwards though, because they didn't tell me how many electrons, they just told me how many coulombs. So I'm basically trying to figure out how many buckets would I need to hold each of these amounts of charge. The way I'm going to do that is I'm going to divide each number by 1.6 times 10 to the negative 19. So I'm going to divide all 4 of these answer choices and see what I get, and then I'll pick the whole number. It is important when you're dividing that you use parentheses, because when you're dividing by something in scientific notation, it's a longer number with a multiplication sign in it, and if you don't use parentheses when you're dividing, the calculator will not really understand that you're dividing this whole number. It will think that you're just dividing by the 1.6 and then later multiplying by this exponent. So we should be getting these numbers as our answers. If you've got something else, you may have forgotten the parentheses. And answer choice 1 represents half of an electron. Answer choice 2 represents 2 electrons. 3 represents 0.75 electrons, and 4 represents 2.56 electrons. So we're going to pick answer choice 2 because that is the only one that represents a whole number of electrons.